Texas Instruments Innovation Challenge India Analog Design Contest 2013-14. We are students of Chitkara University, Punjab. I am Himanshu Chaudhary.
I am Nawab Singh.
I am Prabjot Singh.
Our project is a multi-utility HOMEBOT. This HOMEBOT is connected to different sensors around the house, which are connected to through RF booster connected to our robot.
Our robot has two brains, microcontroller number 1 and microcontroller number 2. Both the microcontrollers are MSC 430 launchpad mounted by RF booster pack. Microcontroller number 1 is used for the motion control of the robot and control of the robotic arm. Microcontroller number 2 is used for sensor communications and countermeasures. The next feature of robot has the robotic arm. Robotic arm is used for domestic works like paper picking and tackling with small containers.
This is a microcontroller number 2, which is a second brain, and it is responsible for holding all our sensory systems. Suppose there is a fire in a house, then this controller will take some countermeasures, one of which it will call to owner using this automatic call circuitry.
Now we are going to start with the burglar alarm. This right here is laser. This is 1M potentiometer. This is light dependent resistor. This is 10K resistor, and this is general purpose transistor BC547. This here is for switching purpose. This is transmitter. This is receiver, and this receiver is going to be implemented on our robot. This receiver is connected with the circuit, and this circuit is connected to our cell phone. This is a connection between cell phone and a receiver. Now we are going to demonstrate the burglar alarm circuit. If some unauthorized person enters our house, this circuit is going to break. I'll show you how. We see that a buzzer goes off, and here's a call connection to the owner. These two things take place simultaneously. Nawab and here the owner is getting called. Now we start with the fire alarm. The components we got here is a thermistor, a 555 timer from TI, a 7805 voltage regulator from TI. The mechanism here is that if this thermistor senses any heat, this provides the astable 555 timer an input. The output from this astable timer is fed to the switching circuit. This switching circuit now starts with the transmitter portion. This transmitter now transmits the information, and this receiver receives this information. Now there are three countermeasures which are taken. The first one is then there's a buzzer which buzzes off. The other one is then there will be a call generated to the owner. And the third one is that we're going to have an exhaust fan which is going to switch on. We do not have the exhaust fan, so we're going to explain it by providing a bulb here.
Let's take the scenario of fire in our house. And they are the three countermeasures of phone call. A buzzer and the exhaust fan. Now the next gadget for our kitchen is LPG detection and its countermeasures, smoke detection and its countermeasures. The sensor we used here is MQ6 LPG gas sensor. This gas sensor, on sensing LPG leakage or smoke, gives a high digital output from these pins. Then this output is fed to the switching mechanism, then to the receiver part. This receiver acts as a transmitter which transmits the signals to the receiver booster pack. This booster pack takes three countermeasures according to the situations, like First it switch on a buzzer, then it make a call to the owner, then it also take a countermeasure of closing the LPG gas valve.
Let's take example of fire in a house. There will be smoke. This here is dark detector circuit. This consists of a 555 timer provided by Texas Instruments, a 7805 voltage regulator provided by Texas Instruments, a light dependent resistor. We have 22K potentiometer here. This 555 timer works in astable condition and produces about 56 kilohertz of frequency. This here is switching mechanism. In here we use relays. At the time of dark, it automatically switches on one of these light bulbs.
This is the remote control for our robot. There are 4 push buttons. Button 1 for forward movement, button 2 for backward movement, button 3 for left turn, and button 4 for right turn. These buttons are connected with the RF booster pack, which in turn send the control signals to the receiver part mounted on the robot.
Now we're going to see our robot turning around an obstacle. Now we're going to have a look at our robot facing some of the obstacles.
Let's have a look at the different motions of our robotic arm. Now let's have a look at the next segment of our robotic arm. We are going to pick our 9-volt battery from this cardboard through the elbow gripper and robotic arm.
In future, there are many amendments possible in this HOMEBOT. We can add GPS system to this HOMEBOT. We can also add voice navigation system in this HOMEBOT. At the end, we would like to thank Chitkara University, Texas Instruments and our mentors for helping us out through this project.